Hi guys! Welcome sa enginerdmath channel. Sa video na to ay tuturo ko sa inyo ang Cartesian vectors in 3D. So kung gusto niyo itong matutunan, just keep on watching. Okay, so this time ay ituturo ko naman sa inyo ang Cartesian vectors in 3D. So actually, part 2 na siya nung Cartesian vectors video ko, which is yung part 1 is about Cartesian vectors in 2D. So basically, meron lang tayong xy plane or yung vector lang natin ay may x at y components. So dito, kapag Cartesian vectors in 3D, parang vectors in space na siya. Meron na tayong 3 dimensions. So consider natin yung x, y, at z component ng vector. So, hindi nyo pa napapanood yung part 2 ko ng Cartesian vectors, ay link ko na lang para ma-check nyo, para somehow meron na kayong understanding dito sa Cartesian vectors in 3D. Okay? So, meron ako ditong illustration. So, sabi, suppose we have a vector f in space. This vector is resolved into its rectangular components as f is equal to f sub xi plus f sub yj plus f sub ck. So, alam naman natin dun sa previous video ko na pwedeng i-resolve yung isang vector into x at y components. So, this time, kapag vectors in 3D na nga tayo, magkakaroon lang tayo ng additional component, yung z component. So, minumultiply natin yung bawat component na yon sa unit vector direction. So, para sa x-axis, ang unit vector is nire-represent as I. Para sa y-axis, ang unit vector ay nire-represent as j. And this time, kapag z-axis, ang ginagamit nating unit vector is k. Okay? So, ito yung illustration natin. So, ito yung actual force F na niresolve natin into its x, y, at z components. So, meron na tayong x-axis, y-axis, saka z-axis. So, yung bawat component niya, let's say itong f sub x. So, ito siya. Ito yung vector niya, yung f sub x unit from the origin. Okay? Tapos, yung f sub y, ito naman, f sub y unit from the origin. And then, itong f sub z, f sub z to. Ito naman yung magnitude niya. Okay? Now, pag kinuha natin yung intersection nitong tatlo, dito sa x-axis dito, sa y-axis dito, then sa z-axis, bale dito. So, ito ngayon yung direction ng ating endpoint ng ating vector f. So, mapapansin nyo, meron tayong unit vectors I sa x-axis, j sa y-axis, at k sa z-axis. Okay? So, lahat ng vectors na to is may magnitude lang na 1 na nagre-represent lang ng direction ng x, y, at z components ng vector in their respective directions x, y, at z-axis. Okay? Now, kung mapapansin nyo, meron din tayong mga theta. So, meron tayong theta x, theta y, tsaka theta c. So, itong theta x, ito yung angle between the x-axis tsaka ng vector f. So, mapapansin nyo, ito siya. Diba ito yung vector natin, tapos ito yung z-axis. Yung angle between them is theta x, same as yung angle between the y-axis saka ng vector f is theta y. And then, lastly, yung angle between the vector f and the z-axis is itong theta z. So, nagde-denote din sila ng direction ng ating vector f. Okay? So, the scalar component of f are f sub x is equal to magnitude of f cosine theta x, f sub y is equal to magnitude of f cosine theta y, and f of z is equal to magnitude of f times cosine theta z. So, pwede nating i-represent yung value nung magnitude nung x component, y component, at z component ng vector by just multiplying the magnitude each to the cosine of the respective theta. So, for f sub x, magnitude times cosine theta x, f sub y magnitude cosine theta y, and f sub z magnitude times cosine theta z. So that f is equal to magnitude of f cosine theta xi plus magnitude of f cosine theta yj plus magnitude of f times cosine theta zk. So, pag sinubstitute lang natin itong value ng bawat component na to, kasi meron tayong f sub xi, f sub yj, tsaka f sub zk, yung formula natin to, sinubstitute lang natin isa-isa dito sa formula ng f. Okay? And then, yung magnitude ng f is denoted by, so ito yun yung naka-absolute value f. Parang Pythagorean lang din, square root of sum ng squares ng bawat x, y, at z component. So, magnitude of f is equal to square root of f sub x squared plus f sub y squared plus f sub z squared. Okay? So, having this form of vector f, kung meron kayong given na theta x, theta y, tsaka theta z, as well as yung pinaka-magnitude ng f, ay mabubuo nyo yung pinaka-form ng equation ng ating vector f using this formula. Okay? Now, the direction of f is specified by the direction cosines. So, this time, di ba alam natin na meron tayong respective theta between dun sa vector f, dun sa x, y, at z axis. Ngayon, kapag hinanap natin yung cosine ng bawat theta na yon, tinatawag silang direction cosines. So, for x, meron tayong u sub x is equal to cosine theta x, then u sub y is equal to cosine theta y, and u sub z is equal to cosine theta z. So, actually, inalis lang natin yung magnitude dito na f, kasi unit vector ito. So, imbis na meron tayong magnitude dito na f, ginawa lang natin lahat na 1. So, kaya naging cosine theta x, cosine theta y, tsaka cosine theta z. Nagiging component to ng unit vector in the same direction as f. Okay, kasi pwede natin i-write tong f as f sub u sub xi plus f sub u sub yj plus f sub u sub ck. Kasi itong ang u sub x, u sub y, tsaka u sub c is mga direction cosine, right? Okay, nakalimutan kong lagyan ito ng magnitude. So, parang pareho lang sa form kanina. Pag sinubstitute natin itong equivalent na cosine theta x, cosine theta y, tsaka cosine theta c, ginawa lang natin u sub x, u sub y, tsaka u sub c. Ngayon, pag finactor natin yung magnitude f, magkakaroon tayo ng magnitude f multiplied by u sub xi plus u sub yj plus u sub ck. Ngayon, pwede nating i-rewrite itong vector na to as a single u. Itong single u, tinatawag natin tong unit vector kasi yung magnitude niya is 1. So, pag divide natin to both sides by the magnitude f sub f, okay, masasolve natin si u. At tinatawag siyang unit vector in the direction of f given by u is equal to the vector f over the magnitude of f. Or, pag sinubstitute natin, vector f divided by yung formula natin for the magnitude ng f is ito, right? Or, representing this actual vector into its x, y, at z component divided by the magnitude f. So, pwede nating i-distribute itong magnitude f sa denominator sa bawat x, y, z component. So, magiging ito siya. And then, pag in-equate natin dito sa vector u, dapat yung bawat I, j, k direction is mag-i-equal, right? So, equate lang natin yung u sub x dito sa f sub x over magnitude f, so kaya ito. And then, di ba kanina equal din sa cosine theta x? Same as ito sa u sub y, equate natin sa f sub y over magnitude f, then equal sa cosine theta y. And lastly, u sub z is equal to f sub z over magnitude f equals to cosine theta z. So, ito yung mga components ng unit vector u in the same direction as f. U sub x, u sub y, u sub c. So, pwede natin gamitin itong mga formula na to para ma-determine natin itong unit vector. Okay? Now, let's have the relative position vector. So, kasi kanina yung kinonsider nating vector f is yung starting point niya, kung mapapansin nyo, is dito sa origin, right? And then, yung endpoint niya is ito, which is determined by the f sub x, f sub y, tsaka f sub c. Or in rectangular coordinate, x, y, z, point in 3D, right? Ngayon, other than the origin, pwede ring mag-start yung isang vector sa another point in rectangular coordinate system, then pointing towards another point. Okay? So, for example, meron tayong 2 points na A, which is x sub 1, y sub 1, z sub 1. Ito. And then, meron din tayong point na B, which is x sub 2, y sub 2, and z sub 2. So, pwede nating mahanap yung vector AB, meaning, from the starting point A, hanapin natin yung vector pointing to point B as having this formula. So, susubtract lang natin yung respective x, y, at z components nila, then multiply by doon sa corresponding unit vectors in x, y, at z axis na I, j, k nga. So, kaya ito yung magiging vector AB natin na may value na x sub 2 minus x sub 1 times I plus y sub 2 minus y sub 1 times j plus z sub 2 minus z sub 1 k. Okay? Take note na mahalaga dito yung direction. So, kapag sinabing vector AB, magsisimula tayo sa point A papunta sa B. So, magiging iba yung ating vector kapag kinonsider natin yung vector BA. So this time, ang starting point natin is itong point B papunta sa point A. So instead na ganito yung direction niya, pababa. Okay? Same lang sila ng magiging value, kaso negative lang. Oppositely directed silang dalawang vector. Okay? So kaya sinabing relative position vector. Relative doon sa given values natin nung pangalan nila. So kung AB mula point A papunta sa B, kung BA mula point B papunta sa A. Okay? Same lang din sa formula sa vector F. Pag hinanap natin yung magnitude ng vector AV, yung bawat component natin, yung x, y, at z component, square root tapos sum of squares lang nila. So ito. Okay? Then para mahanap natin yung unit vector, the same direction as doon sa vector AB, yung formula lang din kanina. So yung vector AB divided by the magnitude niya, or kung i-rewrite natin tong vector AB, in this form, so ito siya, divided by magnitude AB. And then, pag distribute natin, so, pwede natin i-equate, bale, yung u sub x dito sa x sub 2 minus x sub 1 over magnitude AB, then cosine theta x, so parang nandun sa kanina. Then, u sub y is equal to y sub 2 minus y sub 1 over magnitude AB equals cosine theta y, and u sub z is equal to z sub 2 minus z sub 1 over magnitude AB equals cosine theta z. Okay, so same lang naman din to doon sa previous vector F. Okay? Now, meron din tayong vector combination using rectangular components. So, just like dun sa vectors in 2D, pwede rin nating i-add or i-subtract yung bawat components nung any given vector. So, for example, kung meron tayong given, let's say, vector A na to, and then given vector B na to, kapag in-add natin yung vector A plus B, i-add lang natin yung corresponding components nila sa x, y, tsaka sa z components. So, meron tayong a sub x plus b sub x. So, add natin yung x component nila. Then, multiply lagi doon sa unit vector na I. Plus, add natin yung y component nila. So, a sub y plus b sub y times doon sa unit direction in y-axis na j. Plus, add natin yung z component nila na az plus bz. Multiply by the unit vector in z direction. Okay. Okay, so kung minus naman, ma-minus nyo lang. So, a minus b is equal to a sub x minus b sub x times I plus a sub 1 minus b sub y times j plus a sub z minus b sub z times k. So, madali lang siya kapag given na yung actual vector. I-add or i-subtract nyo na lang yung bawat respective components sa isa't isa. Okay? So, para ma-illustrate natin yung concepts at formula na na-discuss natin so far for Cartesian vectors in 3D, ay mag-solve tayo ng examples. So, given vector A equal to 2i plus 5j plus 7k, vector B equal to negative 2i plus 4j minus 6k, and vector C is equal to 3i minus 9j. A, find a unit vector in the same direction as A. B, find A plus B minus C. C, find magnitude of A plus B minus C. And D, find a unit vector in the same direction as A plus B minus C. Okay, so sa A muna tayo. So, sabi, find a unit vector in the same direction as A. So, di ba, ang unit vector natin doon, bale, is yung mismong vector A over magnitude ng vector A. So, we have yung vector A is 2i plus 5j plus 7k over, so yung magnitude niya is square root of sum ng squares ng bawat magnitude nung bawat x, y, at z component ng vector A. So, 2 square plus 5 square plus 7 square. So, we have, so 2i plus 5j plus 7k, ano yung square root ng 2 square plus 5 square plus 7 square? Square root of 78. So, pwede nyo i-distribute, then 2 over square root of 78i plus 5 over square root of 78j plus 7 over square root of 78k. And then, pwede nyo kuhain din yung exact value nito using calculator. So, pwede rin yun. So, ano yung 2 over square root of 78? 0.226i plus 5 over square root of 78, 0.566j plus 7 over square root of 78, 0.793k. Okay, so therefore, this is the final answer. Next, B. Find A plus B minus C. So, combination of vector. So, add natin yung vector A plus B, tapos subtract natin sa vector C. So, copy ko na lang dito lahat ng tatlo. So, i-add natin itong A plus B minus C. So, we have, so, copy ko to, copy, vector A plus vector B, okay, minus vector C. Okay, don't forget to put parentheses. Kasi quantity na yung sinusubtract at ina-add natin. So, combine natin lahat ng I, J, at K components. So, parang combination of similar terms. So, 2 plus negative 2, then minus 3i. Ilan yon? So, negative 3i. Then, sa J naman, 5 plus 4 minus negative 9. So, magiging parang positive 9 plus positive 9. So, 5 plus 4 plus 9 is 9 plus 9 or positive 18J. And then sa K, 7 plus negative 6. Then, wala namang K yung ating C. So, parang 0 yung K niya. So, 7 plus negative 6 lang. Which is positive 1K. Or kung 1, simply K na lang. Okay, so therefore, this is the vector A plus B minus C. Okay, next. C, find the magnitude of A plus B minus C. So, diba ito na yung nakuha nating vector for A plus B minus C. So, para hanapin yung magnitude niya, yung formula is square root nung sum nung squares ng bawat I, J, K component. So, negative 3 square plus 18 square plus 1 square. So, using calculator, ilan yan? So, square root of 334, exact value, and then in decimal, approximately, using calculator, 18.276. Okay? Then, for the letter D, find a unit vector in the same direction as A plus B minus C. So, parang sa A lang din. So, di ba meron na tayong given A plus B minus C vector? So, ang formula, unit vector is A plus B minus C over yung magnitude niya. So, we have, copy lang natin yung A plus B minus C na nakuha natin, 3i plus 18j plus k, over yung nakuha nating magnitude na square root of 334. So, pag in-distribute uli natin, negative 3 over square root of 334i plus 18 over square root of 334j plus 1 over square root of 334k. So, ito yung exact value natin. So, pwede nyo rin gawing decimal, compute nyo through calculator yung exact value ng bawat components. Okay? Next, we have given 2 points P with coordinates 1, negative 2, 3, and point Q with coordinates negative 2, 5, 4 in rectangular coordinate system. Find A, vector PQ, B, vector QP, and C, unit vector in the same direction as vector PQ. Okay, so yung formula natin kanina, let's find the vector PQ first. So, dapat, ang reference natin is starting point si point P, then going to the second point Q. So, parang ito yung x sub 1, y sub 1, z sub 1, then x sub 2, y sub 2, z sub 2. So, therefore, yung formula is x sub 2 minus x sub 1 I plus y sub 2 minus y sub 1 j plus z sub 2 minus z sub 1 k. Substitute lang natin. So, negative 2 minus 1 I plus 5 minus negative 2 j plus 4 minus 3 k. So, we have negative 3i plus 7j plus 1k or k. So, therefore, this is the vector PQ. Now, for B, vector QP. So, this time, kabaliktaran. So, yung starting point natin is Q, tapos yung second point natin is P. So, babaliktaran nyo lang yung position. So, bale, x1, y1, z1, then x2, y2, z2. So, vector QP is equal to, so 1 minus negative 2 times I plus negative 2 minus 5j plus 3 minus 4k equal to positive 3i minus 7j then minus k. So, this is the vector QP. Kung mapapansin nyo, yung mga values ng ating IJK component sa PQ tsaka sa QP is pareho lang. So, parehong 3, 7, and 1, right? Ang naiba is yung sign nila. So, opposite sila, di ba? So, ganun yung equivalent nun. Kapag Binaliktad nyo lang yung letter ng vector, dapat equal sila kaso negative of each other. Okay? Now, for C, kapag naman hinanap daw natin unit vector in the same direction as PQ. So, formula is yung vector PQ divided by magnitude ni vector PQ. So, therefore, kopyahin natin yung vector PQ na 3i plus 7j plus k, square root nung magnitude is negative 3 square plus 7 square plus 1 square. So, we have negative 3i plus 7j plus k divided by, using calculator, ano yung square root ng 3 square plus 7 square plus 1 square? Square root of 59. So, gawin ko na lang exact. Distribute ko lang tong square root of 59. So, negative 3 over square root of 59, I, plus 7 over square root of 59, j, plus 1 over square root of 59k. So, this is the exact value of the unit vector. Pero, pwede nyo rin i-compute sa calc yung decimal value by using calculator. Okay? Next, we have the cable attached to the eye bolt in figure below is pulled with a force F of magnitude 500 pounds. Determine the rectangular representation of this force. Okay, so this time, application na ng vector, which is, kailangan nating mahanap yung representation daw ng force na to in vector form using rectangular coordinate system. Okay? So, this time, gagamitin natin yung natutunan natin sa formula sa paghanap ng vector. So, sa figure natin, kung mapapansin nyo, meron tayong XYZ axis, right? And then, yung location nung bolt natin, yung line of action ng force is from point A to point B. Kasi yung arrow nung ating force, so this is the force F, right? Is patungo from A to B. Okay? So, apply natin yung formula na, diba? So, as we all know, force is a vector. So, kailangan natin ng magnitude at direction. So, in particular, hanapin natin yung representation nitong vector force F in rectangular form. Yung meron siyang Fxi plus Fyj plus Fzk. Okay? So, ang given lang natin is yung magnitude niya na 500 pounds, right? So, kailangan natin matransform itong F into this form. So, di ba meron tayong formula kanina na F is equal to magnitude times unit vector. Itong unit vector na to is same direction nitong force F. Okay? So, para mahanap natin yung unit vector, gamitin natin yung formula natin kanina sa paghanap ng unit vector from 2 points. So, di ba given tayong 2 points in rectangular coordinate system, this time, point A tsaka point B. Kasi yun yung line of action ng force F. So, hanapin natin yung coordinate nitong point A. So, mapapansin nyo, sa x-axis, meron tayong 4 feet. So, x is 4. Then, wala tayong y units, right? Kasi nandito lang tayo sa xz plane. So, 0 si y. And then, sa z, meron tayong 3 units upward. So, positive 3. Siya si point A. Then, yung isang point is B. So, mapapansin nyo, yung point B in the y-axis lang. So, ibig sabihin nun, 0 si x, 0 si, meron tayong value ni y, which is given dito na 6 units, right? So, 6, and then wala tayong value ni z. So, yung point B is 0, 6, 0. Now, kapag kinuha natin yung unit vector in the same direction, makukuha na natin yung same direction ni force F. Multiply lang natin sa magnitude niya, then matatransform natin into this rectangular version ng kanyang vector. Okay? So, apply natin. Hanapin natin yung vector AB. Kasi dun along yung direction ni force F. So, formula kanina, sa bala ang point 2 natin is itong B, ang point 1 natin is itong A. So, x sub 2, y sub 2, z sub 1. X sub 1, y sub 1, z sub 1. So, we have x sub 2 minus x sub 1, right? So, 0 minus 4 times I plus y sub 2 minus y sub 1. So, 6 minus 0 times j plus c sub 2 minus c sub 1. So, c sub 2 to. So, 0 minus 3 times k. So, equal to sa negative 4i plus 6j minus 3k. Okay. Kailangan lang natin is unit vector, right? So, divide natin to sa magnitude niya na AB para mahanap natin yung unit vector in the same direction as vector AB. So, we have, divide natin to sa magnitude niya na negative 4 square plus 6 square plus negative 3 square root. So, ilan to? So, negative 4i plus 6j minus 3k divided by square root of 61. Okay? Ngayon, pag i-distribute natin, pwede natin i-distribute, magiging negative 4 square root of 61i plus 6 over square root of 61j minus 3 over square root of 61k. So, ito yung unit vector in the same direction as AB as well as in the same direction as force F. So, therefore, mahanap na natin yung pinaka-vector representation ni force F. Multiply lang natin yung magnitude niya na 500 pound dito sa unit vector na nakuha natin. Or distribute nyo isa-isa. Pag ginawa natin yon, then compute natin using calculator. So, we have 500 times negative 4 over square root of 61i plus 500 times 6 over square root of 61j minus 3 times 500 over square root of 61k. Okay, so using calculator, approximately, anong makukuha nating sagot? So, sa I, negative 256i plus sa j, 384j minus sa k, 192k. So, therefore, this is the required vector for force F. Okay, so mapapansin nyo, mahalaga yung unit vector sa paghanap ng actual vector representation natin sa isang force. Okay? Next, we have, referring to the figure below, determine 1, the rectangular representation of the position vector A, and 2, the angles between A and each of the positive coordinate axes. Okay, so ito yung given natin. So, meron daw tayong vector A, tapos yung magnitude niya is 12 meters, right? Tapos, meron siyang angle between the z-axis na 30 degree, and then, yung component nitong vector A, dito sa xy plane, which is this vector, ay merong angle na 40 degree dito sa x-axis. So, take note, itong 40 degree, hindi siya angle ng vector A with respect dito sa x-axis. Kasi hindi ganito yung itsura ng angle natin. So, hindi siya yung theta x tulad dun sa kanina. But, itong theta na to is from this component ng vector A sa xy plane at sa x-axis. So, paano natin ngayon hahanapin yung pinaka-vector A? So, kailangan natin vector A is a sub xi plus a sub y j plus a sub zk. Okay? So, pwede nating mahanap agad itong a sub zk, right? Kasi, meron tayong angle niya. Diba, formula natin sa magnitude ng z component ng vector, let's say a sub c is yung magnitude ng mismong a times yung cosine ng theta z. Given tayo ng theta z. So, we have magnitude a na 12, right? Times cosine theta z is 30. So, ano siya? 12 times cosine 30 degree is, using calculator, 10.392 meter. Okay, so tapos na tayo dito. Kulang na lang is itong x component tsaka y component. So, para natin mahanap yon. So, pwede natin gawin is i-consider natin yung component nitong vector A na to dito sa xy plane, which is this component, right? Itong naka-bold na to na black. Paano natin makukuha? Sa pag-draw kasi natin itong right triangle, so parang meron tayong rectangle dito, right? So, maalala nyo, itong vector na to, yung z component ng A, tsaka itong vector na to, parang yung resultant nila is itong A. So, ito ay right triangle, right? Itong dalawa. So, pwede nating mahanap itong component na to, which is equal dito. Parallelogram law, right? So, pag nakuha natin tong component na to, tsaka natin ngayon i-resolve itong vector na to into its x at y component. This time, dito sa xy plane na lang. So, parang ito yung magiging vector a sub x, tapos ito si vector a sub y. So, makukuha na natin yung a sub x saka a sub y component ni a. So, kunin muna natin to. Itong naka-bold na to. Yung 40 degree with respect to the x-axis. So, di ba kapag itong component na to, sine ang gagamitin natin. Right? Kanina, cosine kasi horizontal component. This time, it acts as the vertical component nung vector A. So, therefore, itong vector na to, let's say, vector AXY, yung magnitude ni A times sine 30 degree. Okay? So, yung given angle is 30 degrees. So, substitute. So, 12 times sine 30 degree is what? 6 meter. Right? Ngayon, meron na tayong magnitude nitong vector na to, 6 meter. Which is the resultant na of the x and y component nitong vector A. So, ang angle na yun na given is 40 degree. So, parang ito yung right triangle natin. Ito. So, ito yung right angle. So, parang ito yung hypotenuse. So, meron tayong 12. Paano uli kuhain yung a sub x saka a sub y component? So, yung a sub x is cosine, right? So, cosine 40 degree times yung magnitude na nakuha natin na 6. 6 to 6 yung nakuha kasi natin, diba? So, 6 times cosine 40 degree is what? Using calculator, 4.596 meter. Then, yung a sub y is what? This time, sine naman, diba? So, 6 sine 40 degree is, using calculator again, 3.857 meter. So, kumpleto na tayo. So, therefore, yung vector A is, ano yung a sub x natin? 4.596i plus, ano yung a sub y? 3.857j plus yung nakuha nating a sub k kanina na 10.392k. Okay? So, take note, positive lahat sila kasi nga nasa first quadrant. Positive si x, positive si y, positive si z. Ngayon, ano pa yung hinahanap? The angle between A and each of the positive coordinate axes. So, kailangan natin yung theta x, yung theta y, tsaka itong theta z. Itong theta z given na, di ba? Ito na lang theta x saka theta y. So, para makuha yon, meron tayong formula kanina, di ba, na cosine, let's say theta x is yung x component over magnitude ni A. Right? So, nakuha na natin yung magnitude ni A sub x. Ano yon? 4.596 over magnitude ni A is 12. So, para makuha si theta x is r cosine ng 4.596 over 12. So, using calculator, approximately ilan ito? 67.5 degree. Then, using the same principle, theta y will be yung y component na nakuha natin, 3.857 over same magnitude ni A na 12. So, r cosine din. So, using calculator, ang value ni theta y is 71.3 degree. Then, yung theta z, kahit i-compute natin uli, r cosine this time, yung z component na nakuha natin is 10.392 divided by magnitude ni A na 12. So, dapat, makukuha pa rin natin is 30 degree. Okay? So, therefore, ito yung theta x, theta y, tsaka theta z ni A. Okay? Okay, so I think that's it for this video, Cartesian Vectors in 3D. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.